In today's class, we're going to talk about the power of a compounding, which means you put the money in the bank and the bank will pay you interest, right? So you earn some interest from the bank. If you leave the money in the bank for a certain time period, for example, like a 1 year or 10 years or maybe 20 years without touching it, at the end of that time period, you're going to get the money back. And that money will include your interest, your principal plus the interest. So first of all, we will like to make sure that we speak the common language and we use the same letter everywhere. Okay, so P, we use that, which is the principal, and that is in dollars, and that is the money you put in the bank at the very beginning. And the second one is APR. That's the annual percent rate, or you can just simply use the letter R. So that's annual percent interest rate. Usually is given by percentage. For example, like 5%, which is pretty common you see right now. And usually when we put in the calculator, we change that into 0.05. This is like a rewriting from percentage to the decimal form. And I hope that you already know that. So 5%, you just use 0.05. Okay, so that's a P, that's a APR. And what we're looking for is the A, is the final amount after Y years. That's that's the time of the year that you put your money in the bank. Now, first, let's do something called a simple interest. Simple interest. For simple interest, the formula is this: A equals P times 1 plus APR times Y. Okay, and the second one is called compounding periodically. So compounding periodically. Okay, so if it's a compounding daily, which means the bank will calculate the interest at the end of a day and then find out how much interest you earned in that day. And the second day, the bank will pay you the interest based on your principal plus the interest you earned on the previous day. And then the day 3, they're going to pay you the interest based on your principal plus the 2 days interest you earned already. So for daily, and we use a little n, this n shows the number of a period in a year, number of a compounding period in a year. So when it's a daily, we use a 365. When it's monthly, we use n equals 12 because there are 12 months in a year. So that's this n is a special letter that we use here, and we always use n. That shows the number of compounding period in a year. Okay, so if it's annually, then that n will be 1 because it just compound the period at the end of a year. There's only one compounding period in a year. And the last one is called compounding continuously. Compounding continuously, which means the bank will give you the interest every single moment. And then next moment is going to give you the interest based on the interest that you earned in the previous time plus the principal. So there's no like a certain time point that they stop and they calculate the interest. And they just keep growing, okay? Keep going that. So the formula was this: A equals P times E to APR times y. Okay, for the compounding period, there's a formula that I forgot to write here, which is A equals P times 1 plus APR. This APR is the annual rate. You divide it by N, that will give you the periodical rate. And then the power is N times Y. So that's the number of years. This is how many compounding period in a year. If you multiply that, it will give you how many compounding period in the whole time period that you leave the money at the bank. Okay, so once we know this, let me just highlight these three formulas. Okay, and then we're gonna use some real number to find out what is going on, which one is the better one, which one you prefer to use. Okay, so let me just do that. Okay, let's assume that you have the principal of $8,000. $8,000. So you translate from English to math. This is the math language. P equals 8,000. And the APR, let's say right now is 5%. Of course, you're going to write that as 0.05. Okay, if you leave the money in the bank for 10 years, so Y is 10. All right, now number one, if the bank pays you simple interest, how much money you're going to get at the end of the year. So what we're looking for is, what is A? What is the final amount? So my A, we're going to use this formula, so A equals P times 1 plus APR times Y. Therefore, my A equals principal, that's $8,000 times 1 plus 0.05 times 10. Let's see how is that. And I'm going to show you how to do this in the calculator. Okay, we always starting from this APR when you plug the number in the calculator. See, APR is a 0.05. So use my calculator. You do 0.05 times 10. The good thing for this new updated system, you don't have to hit equal. You just keep going. You plus 1. And then make sure that you watch this line to make sure that they're doing the right thing. So that's this part. And because there's a parenthesis, so you are going to hit equal now. You need to hit equal so you can get what is inside the parenthesis. But the good thing is you don't really need to write down the answer. So let me just do that, equal. So that's the value you have, or that's the answer for the parenthesis. And then you multiply by $8,000. Did you notice that I multiply by this 8,000 at the end? All right, so my answer is $12,000, which means if I put $8,000 in the bank for 10 years, the bank pays me 5% interest rate, simple interest. At the end of 10 years, I will have this much. So number two, what about if you put the money in the bank still pays you 5%, you still leave the money there for this amount, for this principal for 10 years. And what about the bank compound interest annually? Annually means N equals 1, right? Okay, so then I'm going to use this formula. So my A equals 8,000, that's the P, and then multiply by 1 plus APR on top, 0.05 over N is 1, and the numerator and the power is 1 times 10. All right, now how do you do that? I would do, again, I use 0.05. I always start from here. So 0.05 divided by 1. Okay, you don't really need to if you already know that any number divided by 1 is the number itself. So you plus 1 and then equal. So that's this part. Now the next tricky part is what are you going to do for this number 1.05 to the power of 10. To the power of 10 means 1.05 times itself altogether 10 times. However, we have one little function here on the calculator. If you see that, it's x to the y power. So you just hit x to the y power. It seems like nothing happened, but actually the calculator is waiting for you to enter this power. And this power is 1 times 10. Of course, if you know that, it's just 10, right? So you can just enter 10. If you are not familiar with this, you can use this parenthesis. See? So you use a parenthesis. You see what happened here? So the calculator is going to work on the power part. So you do 1 times 10. Of course, you don't really need to close the parenthesis. You don't really need to. You can just hit 10. And then that is this power part equal, and then times $8,000. So multiply by this 8,000 as your last step. So that's your answer. So you get a $13,031.16. When we deal with money, we always keep 2 decimal places. Okay, sounds good, right? So this is a compounding annually. So number 3, let me do compounding monthly. For that case, n will be 12. So my formula, I plug in the number, is going to be $8,000, so just like this one, times 1 plus 0.05 divided by 12 to the power of 12 times 10. All right. Calculator, when you use calculator again, you're going to start with this is 0.05 divided by 12. Okay. Again, I don't want you to write down the answer in the middle because see what happens if you do that. You have to copy all those numbers to make sure that your final answer will have very, very small compounding rounding error. So I would do is stop writing the answer. I use this way, starting from 0.05. In that way, I can avoid writing down the answer in the middle. So 0.05 divided by 12, okay, and then I multiply, and then I plus 1 equal, all right. Again, I do not write down this number because this number has so many digits. I'm lazy. I don't want to write that number. Next, I need this number, take that to the power of x to the y, ding, okay, to the power of 12 times 10. So I use the parenthesis, 12 times 10, close the parenthesis. See, that's this part. And then I multiply by 8,000. So times 8,000 equal. That would be 13176.08. Okay, so number 4. What about a compounding daily? If you do compounding daily, my n, I take 365. And then I plug the numbers into the formula. It should be $8,000. 1 plus 0.05 is the annual rate. If you divide it by 365, you get the daily rate. So that's 1 plus the daily rate. But because you compounded so many times, how many times? 365 times in a year for 10 years. Okay, so we're going to use the calculator again. 0.05, 0.05 divided by 365, which is this fraction, and then plus 1. Okay, since I have this parenthesis, I just hit equal. And I don't need to write it down. I just need to bring up to the power of. You can easily see this is a 3650. But if you don't know, you can just use the parenthesis, 365 times 10, close the parenthesis, see? Okay, and then after you finish this, you're going to multiply by $8,000. That's your principal. So the answer you have is 13189.32 cents. All right, so far we look at this, simple interest will only give you $12,000, but compounding interest is much higher, right? It gives you at least $1,000 or more. But the compounding annually, monthly, daily, the more frequently they do compounding, the more money you're going to have. See, 13,000 is the same, but here's only $31, here's 176, and here's 189. So the more frequently it compounds, then you're going to get a more interest. That makes perfect sense. So what about the number 5, compounding continuously? That means for every single moment, continuously, every single moment you get the interest. And the formula is a little bit strange. The formula is this: A equals P, sorry, I just plugged in the number, 8,000, okay, times E, APR times Y. So it's 0.05 times 10. All right, now, in order to figure this out using the calculator, I want you to pay attention to here. Did you see here? It's e to the x. Okay, so that's that e. Do not worry about this if you don't know what is e. You know what is e? You can just click that, and then you can see e equals this. E is a number. It's a natural base. But if you haven't learned that, don't worry about that. It's 2 point something. Okay, so we're going to start again with this APR on the calculator. So 0.05 times 10 equal. So you can find out what is the power here. After you figure out the power, you click this e to the x, this power. You see that? It's e to the power of, and this is 0.5. And then you multiply by $8,000. Guess what? Because we said that the more frequently you do the compounding, the more money you're going to have at the end. So if the bank pays you the interest, the compounding continuously, you should have more money than even the daily one, right? Is that right? Okay, so I got 13189.77. It's true. It's higher than that. All right, now I would like you to pay attention to this. This is how much you get by simple interest. This is annual. The compounding annually, monthly, daily. Okay, simple interest will give you the minimum, right? That's the smallest amount. Even the bank pays the same interest rate for the same time of the year for your same principal. And this would be my favorite if the bank pays you interest compounding continuously. Most of the time it's going to be this. So you can tell that this is pretty good. From here to here, it doesn't vary that much. Did you see from here, the difference is only like $13. Of course, if your principal is higher or the interest rate is higher, it will make a little bit bigger difference, but this is good enough. A lot of banks would choose to do this. I don't see any bank pay you the compounding continuously interest, and it doesn't really vary too much from the daily compounding. Okay, so if the bank says, do you want to have a simple interest rate or you want the compounding monthly? Of course, you choose the compounding monthly one. And this shows you the power of a compounding. So if you have any question, then you can leave a note here and ask me a question. And also, I hope that you write down these 3 formulas and pick some number, pick some principal, APR, and the Y, and then do your own little calculations so you can compare that and find the power of compounding. Okay?